Hello, welcome to 10.1 video. So 10.1 is on square root functions. We're just going to be looking at how to graph these things and then how to find their intercepts. So it turns out this is really easy if you have Desmos. Like really easy. So I'm going to be showing a lot of this stuff in Desmos. But I'm going to start off by just writing the generic version, f of x or y equals, it doesn't matter which one of these you use, one of them's in function notation, and we're going to be leaning on function notation a decent amount this unit. But the general form is y equals x plus h plus k. Oopsies, x minus h. All right, this h and k thing, all this is, and yeah, these two formulas are exactly the same. All this h and k thing is where the square root function starts. So h comma k is the coordinate point of the start of the square root function. And we're going to look next at how to actually build the graph. But for now, I just want to show a couple examples. If you have an equation like y equals square root of x plus 3 minus 2, what this means is that this square root graph starts at -3, the opposite of what's inside here, comma, -2, the thing that's on the outside here. So this looks a lot like point slope form or even quadratics. You remember during quadratics, we said something like, yo, the vertex of this parabola happens at 3, comma 4. Because it's the opposite of this, comma this. And it's the same idea here. We're going to take the opposite of what's inside the square root, that number that's added there, and do comma the number that's on the outside. So another little example, if I have f of x equals the square root of x plus 3, the number that's added on the inside is 0, so it'd be 0, comma 3. Done. That would be where this thing starts. Okay, now let's go and look at how these graph. So for that, we're going to head over to Desmos. This is what a square root graph looks like. It looks like something that starts off a little bit steep. So this one starts at 0, 0, and it starts off pretty steep, and as it goes along, it gets flatter and flatter and flatter and flatter. And that's what square roots look like. And if you are struggling to make sense of this visually, the square root of 1 is 1. So 1, comma 1 is a point. The square root of 4 is 2. So 4, comma 2 is a point. The square root of 9 is 3. So 9, comma 3 is a point. That's how you build this, and you can build this with a table. So we could build a table here. Square root of 1, 1. Square root of 4, 2. Square root of 9, 3. Now, I built this table a little differently from how we've done this in the past, because I didn't do 1, 2, 3, like that. But if I did 2, I would just get the square root of 2. And 3, I get the square root of 3. The only reason I didn't do those is because the square root of 2 and the square root of 3 are big, long decimals. And picking things we know the square root of that are nice numbers makes graphing it way easier. Like if I was trying to graph this from scratch, so I'll just delete my entire square root thing here. Oh, I can just take it off there. All I would do is pick the points that are really easy. Square root of 0 is, whoops, I gotta that button to right. Square root of 0 is 0. Square root of 1 is 1. And then square root of 2 is some fraction, but I know the square root of 4. And I know the square root of 9 is 3. And I could even go a little further. I know the square root of 16, oh darn, 16's over here, is 4, and I could put another dot over here on the edge, and I could build my square root function from that. Okay, so that's how to graph these. Now, let's actually get to business to explain how to do the questions. So they're going to give you some sort of thing like y equals x plus 2 minus 5. And we know from what we did earlier that this would have a starting point at -2, -5. And sure enough, when I click graph, it's down here, its starting point is at -2, -5. Now, the questions on the homework are going to ask you for the x and y intercepts. So if I'm looking for the y-intercept, that's this point right here. So I can click on that point in Desmos, and it finds me the y-intercept. So I click on it, boom, answer. -0, -3.586. X-intercept. I gotta look at where it goes to the x-axis. So I gotta scroll way over here. Cool. That point right there, 23, 0, that would be my x-intercept. And I'm done with the question. So those are the two things I need. So let's make a little different of a question. I'm going to make this a plus this time. I'm going to do like -7. Okay, where's my graph? Oh, there it is. Sure enough, this thing starts at 7, 5, which we can find using our same method or just graphing it here. If I look at where this goes to the x and y axes to find the x and y intercepts, I notice that it never goes through either axis. It starts here at 7, and it goes to the right forever. And it starts at 5 and goes up forever, so it never actually has an intercept. So this is, I would just answer, like never for both of the intercepts, or no intercepts. On the homework, they call it the x or y intercept does not exist. The x-intercept. Whoa, it does integrals when I do that. That's funny. Anyways, the point is you just write it doesn't exist. Okay, and then the last thing to talk about in something we're going to be talking about quite a bit more in this unit, even after today, is we're going to bring back this idea of domain and range. So if you remember, domain is the x values our graph goes through, and range is the y values our graph goes through. Now, the x values our graph goes through is it starts at 7. So it starts at 7 here. And then its x values keep going on until we get to infinity. Like it goes on forever. Now, I put an equal to on the 7 side because it's a solid point at its starting location. And I didn't put one by the infinity because we never actually get to infinity. But x is between 7 and infinity. And y is going to look really similar. The range is going to look very similar. We're starting at a y value of 5. We include that because that point is a solid dot. And we're just going up from there until we get to infinity. And this is how we could write the domain and range. Some of you might be savvy and realize if you just write x is greater than or equal to 7 like this, that's the same thing as x goes between 7 and infinity. And similarly, we could rewrite this one as just y is greater than or equal to 5, and that would have worked just fine for our range. So some options. So I'm going to run through one where I do all of these steps, and then we should be good to go. So I'm going to do x plus 2 minus 1. First thing I'm going to do is find my intercepts, and Desmos makes this so easy. Boom. X-intercept, -1, 0. Y-intercept, 0, 0.414. So, cool. X-int, Y-int. All right, already done with the first parts of the problem. Second part of the problem, domain and range. Cool. My domain is, I just gotta, so -1 is my starting x value, and I'm going to the right forever. So x just has to be greater than or equal to -1. Cool, done. Range. Oh, did I just goof? Oh my gosh, oh my gosh, oh my gosh. My starting value is -2, -1. That means my starting x is -2. Oopsies. That's a -2. And we can see that the little nibbies on the graph are each 2 because it goes over 5 and gets -10. So oopsie daisy. X is greater than or equal to -2. For a range, y also is greater than or equal to something. It starts at a value. The value it starts at is -1. And so I just got to be greater than or equal to -1. So writing domain and range for square roots is pretty easy. Usually, if it's a positive square root, you're just going to be greater than or equal to the starting x value. You're going to be greater than or equal to the starting y value for the range. Okay, that's square root functions. They're pretty family friendly. Remember the easy square roots. So I'll write those out real quick. The easy square roots are family friendly square roots are 0, 0, 1, 1, 4, 2, 9, 3, 16, 4, 25, 5, 36, 6. If you don't know where I'm getting these, you just take all the easy numbers like 0, 1, 2, 3, 4, 5, 6 and just square them. And that's the thing that's easy to square root of. Okay, that's square roots. We're going to be moving on to graphing all the different kinds of functions we learned earlier this year and doing a parent graph assignment. So while today's homework is on Pearson, so it's on ClassLink, and I guess Pearson rebranded. They're calling themselves something different now. What are they calling themselves? Savas, realize. Wow. Thursday's homework is actually going to be a worksheet. So that's going to be a little interesting, which means we're going to have a submission document on my homework calendar, a Google form where you can put in a picture, like a cell phone picture of your homework. That'll work, or you can scan it and send it to me, upload it to that form, but I'm going to have a Google form for that. And I'll talk about that more on Thursday. Wait, Thursday? Friday. So the homework on Friday will be a worksheet, actually, instead of in Sabas Realize. Anyways, I hope y'all are having an okay week. I know the world is a little bit crazy right now, but I care about you guys, and I hope you guys are doing all right. And that's it for me.